Okay, so next moving on, we're going to talk about electrostatic by induction. Now do take note that this is for metals. Okay, so the thing is, why is it metals only for this part and the for rubbing is non-metals? Is because all metals are electrical conductors itself, which means your electric charges, your electrons can move very, very easily throughout. So just now, what happens if you try to rub metal? Okay, if you try to rub metal, what happens is that because you are holding the metal, okay, what happens is when you rub it, what happens is that even though, yes, when you rub it, for example, with a piece of cloth, okay, what happens is electrons are transferred, right? But because your metals are electrical conductors itself, what happens is that your electrons will actually flow all the way to the ground. So what happens is basically this will remain neutral. So even though if you try to rub it, what happens is, yes, electrons can be transferred from the cloth towards the metal itself. The problem is because metals can transfer electrons easily, which means that that electron that you just transferred can actually go all the way to the ground to become neutral. So for the ground will always be a neutral point. So no matter how many charge that you have and you discharge it all the way to the ground will always be zero. Okay, so because of this itself, no matter how much you try to rub a metal, because even if you are standing, because of us, humans can conduct electricity because we have water, we are made of 70% water. So because of this, if you try to rub the metal itself, they will just flow through us towards the ground. So because of this, metals cannot gain charges by rubbing. So we have to use what we call your electrostatic induction or electrostatic charging by induction itself. Okay, so the thing is, induction, the word means without touching. So induction means without touching. So my charged object can become charged, positive or negative charge, without touching it. So if I want to have a negatively charged object at the end, I'll use an opposite charge, which is positive. So for example, how this works is, because I bring this very, very, very positively charged object near my neutral. So neutral means same proton and neutron, right? And sorry, not neutron. Same proton and same electrons itself. So you will notice that the numbers that you have usually will be the same. So for example, you have this very, very positive charge. What happens is that the electrons, okay, the electrons inside, they will move here. So because of the electrons being attracted to your positively charged object, the left side momentarily, keyword, momentarily, so temporarily, it will be, the left side of my conductor will actually become negatively charged, because at this point in time, there are more electrons on the left than on the right. So on the other hand, your right hand side will become a positively charged object. Okay, so because of this, this part becomes negative, this part is positive. Now, if you were to just remove my positive charge, they will just go back to being neutral again. Okay, so before that, while it is still near, what happens is if you touch it, now remember, humans, we are connected to the earth, we are on the earth, right? And because we can conduct electricity, what this means is, because this guy is very, very, very positively charged on the left, what happens is all the electrons from the ground, there's a lot, they're just going to flow into the neutral conductor over here. So what happens is, there will be a lot of electrons from the ground or from the earth that is attracted, and they will transfer into my conductor over here. So over inside here now, this is a lot of electrons. Okay, and basically the number of electrons are so much that your right hand side now is also filled with electrons, so this part is neutral. So now you are only left with abundance, you have excess electrons on your left hand side because they are still attracted towards the positive part. So what happens is, once you remove your hand, you are no longer in contact with the ground, right? So this part is basically, this part becomes neutral, but this part is still negative. Okay, So if you remove the positively charged object, you'll notice that I have 4 charge over here, right? So these 4 charge, because they are all negative charge, what happens is because they are all negatively charged, they will actually repel each other because like charges repel. So what happens is that they try to stay as far as possible from one another. So they occupy all 4 corners or all 4 north, south, east, west from one another itself. So because of this, because I have more electrons, because just now you just added more electrons from the Earth towards into the object, right? So what happens is you end up with a negatively charged conductor because now I have more electrons than protons. Okay, so because of this, I end up having a negatively charged conductor over here. So if I want a positively charged conductor, all I need to do is introduce this very negatively charged object and I'll reverse the process. But now, instead of electrons flowing up into my object, electrons inside will actually flow down to the ground. So now you will end up, there will be very, very little electrons for your, if you do it the other way around. So basically, whatever you see here, everything in reverse will be for the negatively charged object to charge a neutral conductor. Okay, so just try to visualize it bit by bit. What happens over here? You try to visualize it because it is a very stage by stage process. You must first move this closer. What happens? Your electrons inside will be attracted, move to the left, and then what happens? Because you touch it, more electrons from the ground will move into. So now inside you got a lot more electrons. So once you remove your hand, you're no longer connected to the ground. Once you remove your positive, too much electrons, they will repel one another and they'll go to your 4 ends of your conductor itself. But overall, you are now negatively charged because you got more electrons than protons. So apart from this method, we can also do 2 conductors at the same time. We can charge 2 conductors to actually have 2 opposite poles. So now, first things first is keywords. You must be in contact. Because when you touch, electrons can flow freely from X to Y or from Y to X itself. So the thing is, do take note, there is nothing here. Nothing, don't have. You basically treat your X and Y as one object. You don't treat it as separate. So this is your left-hand side, you will have more electrons. Your right-hand side will have, your left-hand side will have less electrons because if you bring a negatively charged object here, all the electrons will move to the right-hand side. They will be repelled away because like charges repel. So what happens is the right-hand side of your 2x and y, they will become more negatively charged, where the left-hand side becomes positively charged because of the lack of electrons. So what happens is, at this point, if you remove the 2 spheres, what happens is, because you remove the 2 spheres, the left-hand side now have less electrons. This side got more electrons. Okay, so what happens is, once I remove this negatively charged object, you'll notice that, hey, this is now positive. This is now negative. So because they are positive and negative, what happens is now they will actually try to attract each other and try to move towards each other. But because they're on the stand, they are not free to move. So they cannot touch each other, because if they touch each other, what happens is that the electrons in Y will move into X. And therefore, both of them will actually cancel out and become neutral again. So basically what this means is, because when metals touch other objects, they can actually transfer their electrons quite easily itself. So you cannot allow them to touch unless you want to do it something like this at the start. Okay, so you will notice all the different pieces. So you end up having one positive, one negative. And if you want to do it all over again, you can repeat the process. Okay, now a few things to take note. All right, now basically the charge induced in my object. So inside here, so for example, this one, okay, cannot exceed the charge of the object. So if you take a look, or this one, for example, if you notice this one, it has 1, 2, 3, 4, 5, and 6, right? So what I mean by this is the positive charges that is built up base of this, right, cannot be more than 6. It must be 5, 4, 3, 2, 1, or 6. It cannot be more than 6. Normally for me, when I'm drawing, I'll usually draw 1 or 2 lesser charges. So in this case, I'll draw like 5 on the left-hand side. And because these two were neutral, if you draw 5 here, this side must also be 5 negative. So 5 positive, 5 negative. Okay, so your total amount must balance if you use neutral. So do take note, okay? So on the next page, let's talk about your word examples. So if you have two identical spheres and they are hanging from a point, so because they're hanging from the string, they can move about freely, okay? So now they're saying P is negative and Q is neutral. So the thing is, if P is negative, okay, so P is very negative, right? And Q is neutral. What happens is, because this is negative, you actually cause the electrons to move to the right-hand side. So what happens is this side will become more positive. Okay, so your electrons will move there. This side will become more positive. This side become more negative. And because this part is positive, this part is negative, they will actually attract each other. So what happens is that they will actually move towards each other. All right. So how do I explain this point? Okay, so what happens is the electrons in Q will be repelled by the negatively charged sphere P, since like charges repel. Okay, so what happens is the left side of Q becomes negatively charged, while the right side becomes positively charged. Oh, sorry, I said it wrongly. It's the other way around, positively, and this side is negatively. Okay, because on the right-hand side, you have more electrons now. So since unlike charges attract, spheres P and Q will move towards each other. Okay. So a bit long-winded, but basically you have all your different points over here. Is you will repel this, and what happens is afterwards. So there's 3 points that you need to take note. Electrons, first thing, because this is very negative charge compared to Q, the negative charge in P will actually repel the electrons in Q to the right-hand side. And because now you move the right-hand side, left-hand side is positive, right-hand side is negative. Since unlike charges attract, P and Q therefore move towards each other. Okay, now if P and Q are negatively charged, okay, so P and Q now is both negative. Okay, and if you notice, they actually expanded more and they tell you specifically they have the same number of electrons. So what happens is, first thing, most likely is they will actually repel each other, right? So you want to say that since like charges repel, since like charges repel, spheres P and Q will move away from each other. Okay, so once they remove, then what happens is, because they are actually gonna be moving away from each other, right? And they have the same number of electrons. As they have the same number of electrons, they have the same electric charge. Hence, the spheres P and Q will remain repelled. Will remain, how to say, they'll be basically at a distance. They remain at a distance from each other due to the repulsion. Okay, and if you notice, they will look something like this. I'm just going to draw a quick sketch. Basically, is P and Q will basically be at a distance away from each other. Okay, so they will actually remain at the distance itself. So you take note, basically it will be something like this. Okay, so let's just double check what did I trace properly. So you can see over here, they will actually have like charges repel, they repel away, right? So what happens is, okay, so this one is being a little bit more specific itself. They will actually be displaced at the same angle and remain in that position. Why? Because they have the same amount of charge and they are action reaction pairs. So this action reaction pair not so much, but because they actually have the same amount of charge itself. So basically the part that I was missing, so just now what I wrote here, right? Okay, so this part, where did I go wrong? Basically, you want to say they remain at the same distance away from each other. So they remain at the same distance away from each other due to the repulsion itself, or you just want to kind of say that this part is the one that is a little bit more quirky. So you need to pay attention to this part. Okay, but basically just now, when I was typing out the answer itself, normally this is how I broke down the question, how I approach it, right? So you just need to be a little bit more careful itself. If not, see if it's possible to use your illustration or anything to kind of back up your answers. You know what I mean? So P and Q itself will be displaced from the vertical, will be at the same angle, and they will actually remain in that same equilibrium position itself. Because this kind of question, what happens is, it is possible that they actually ask you to find vectors. You have your weight, you have your tension, and you have your electric force. So because of this, it is possible that they actually ask you to draw tension, and then they ask you to find the equilibrium. So vector diagrams, all of those are all possible itself. So don't forget, electric force is still a force. So whatever you learn in your dynamics can still be applied and combined to give you a harder time. Okay, so you need to be very, very careful itself. So do take note about all the subsequent parts. Okay.